Okay, welcome back everyone. I hope you had a splendid lunch. Now let's talk about accounts under the bonnet. So, what's on the agenda? How accounts work under the bonnet, what a Corda leveraging accounts might look like, so we'll look at some code samples and things like that, and then performance and other implications. But to be honest, we'll spend most of our time on how accounts actually work, as opposed to performance and other stuff, which is actually not as big a deal as you might think. So, anything that's not covered here that you guys would like to cover? We can maybe do some Q&A at the end.
Are you going to cover off node signing roadmap or anything like that?
I mean the out of so Case is going to talk about wallets a bit later on. So is that covered?
Sorry. No, it's friendly. I just wish we asked.
Yeah.
Okay,
We are
cool.
going to.
So yeah, in Case's session at the end of the day, he'll be covering that.
Right.
Eric?
Does that fit in the concept of micronodes?
Micronodes.
You wanted the white paper.
I don't know what micronode is. Case maybe no.
Yeah, we can talk about that.
Okay, good.
Oh, is this the mic thing? Mic home thing?
Yeah, I think it's the technical white paper up there.
Oh, okay, I haven't read it. Okay, so
I think one time.
how does it all work? There's basically a bunch of database tables. There's a bunch of database tables that keep track of mappings, basically, and that's literally all it is. Unfortunately, there was a lot of work that had to be done in Corda core to facilitate all of the account stuff, and it's been a gradual process of about 9 months. I mean, the process actually started before Corda 4. So in Corda 3, we started adding the first few mappings, and then in Corda 4.1, 4.3, we've added even more. So it's a piece of work that spans a long time, and it's really been changing things, changing the implementation of the identity service, the key management service, and the vault service. And I'll go into a bit of detail around how all of that works in 2 slides' time.
Roger, just off the back of what you just said, is there a minimum platform version for accounts? Do you have to be on 4.2 or something?
You have to be on 4.3
4.3?
because it uses APIs in 4.3.
Okay, thanks.
So yeah, it's a good question.
Do the other nodes also have to be on 4.3 to understand?
No, they can be on. They would have to be on at least 4.0 doesn't work, so 4.1 probably you want to be on minimum, I'd say. But I mean 4.0 is buggy basically, so you want to use 4.1 as a minimum, I'd say. So the idea is if you're using accounts, it's a loose coupling, right, to everything else. So the only thing in a state object, so at the wire protocol level, that accounts needs is the public key, which already exists, right? So everything is mapped via public keys. So using accounts doesn't change the wire protocol or anything like that. So it only changes things at the local node level for you, and you can interoperate quite easily with accounts that don't have with nodes that don't have accounts.
Doesn't the underlying code use the confidential identities by doesn't that imply that the counterparty node has to have that, or does not imply then that they have to be 4 point something?
Depends what you're doing. So if you're having to request keys, then yeah, but if you're just observing transactions, then it doesn't matter. I guess it depends whether your workflow requires that confidential identities thing. I mean, if you wanted to, you probably could use the old confidential identities version with the new confidential identities version with accounts. I mean, I wouldn't recommend it, but it would still work, I suspect.
We kind of do what you just said in SDX. So I guess if anybody wonders, if you absolutely need 4.3 to use any of the accounts functionality, then SDX are proving that no, we are running on 4.1 or something, and they have their own accounts which are not that dissimilar to this. It's based on your ideas that you presented to them in January.
There yeah, okay. But yeah, if they want to use the new APIs, then they're going to move to 4.3. Yeah.
By the way, this video, this session might go external, so if we...
Stop talking about customers.
Yeah,
But
don't
I'm using code names anyway, so SDX is a code name for storing a big line.
Of course it is.
It's double block. Yeah.
Oh yeah, sorry, no, that's a code name, yeah.
Unless, of course, we need it to go into more detail, in which case we'll just restrict it, but if we can leave it so it's able to go external, then that would be more useful.
Okay. No editing required.
Leave the name out.
Yeah. Okay.
You have to restart the session. Maybe not.
All right. Thank you, Matthew.
Those start a client name, is that what you...
No, it's not. So, as I noted before, accounts and confidential identities makes extensive use of new APIs on the identity service, and we're going to talk a little bit. Oh, sorry, a little bit about those later. But just to kind of emphasise, like how it all works. States are mapped to accounts via participation keys. That's very crucial in this whole design. The whole thing pivots around the participation keys in state objects. So here we've got the fungible token state object, and it's got a holder, which is an abstract party. So that's a party without any X500 name, it's just a public key. And if you store this state in your vault with the public key, with a holder, a public key, that is assigned to an account on your node, then when you query the vault for that specific account, then it will return that state. And it won't return other states that have been assigned to other accounts. Right? So everything is done through the public keys, through the holding keys, through the participation keys. So the way it works is, create a new key pair, map it to an account, use that public key to participate in a state. Now that state, assuming the transaction gets committed to the ledger and the output state gets stored in the vault, then that state is then owned or belongs to the account that the public key is mapped to. Does that make sense?
Maybe worth to say, Roger, it's not the whole, it's not like a magic field, it's the list of participants.
Yeah, exactly. So as Stefano knows, we haven't added anything new to the state object. This is literally just the participants field, which is not illustrated here. Here in the fungible token, the participants is a list of one item, which is the holder.
So that's fine for anything that inherits from fungible state. What happens if it inherits from contract state?
This doesn't inherit from contract state. Contract state has the participants list in, which is used
So
to map public keys to accounts.
How does holder correspond
Participants
to
equals
Participants, so you just do override val participants get parentheses equals list of brackets holder and bracket, and then that's it.
Right. Okay. Okay. Cool. So
Okay.
so it's not limited to. Okay. That's great. Thank you.
but only one. So you'd only want one thing in your participants, unless you want to have multiple accounts owning something.
Well, that's what I'm thinking. So I'm thinking about use cases where it's not. It's not a token style thing.
All right, ignore the fungible token. Just think of it as a contract state with multiple participants. Each one of those participation keys can be mapped to an account. And if you store that state in the vault, then that state will be mapped to whatever accounts that the...
Okay, so you can use, the bottom line here is you can use confidential identity with any type of state.
Yes.
Okay.
Okay. Right, how does it all work under the bonnet? So we have the key management service that stores a list of public key hashes to public keys and private keys. It stores public key hashes because public keys are large, they're not very good for the purposes of indexing and performing equality checks and things like that. So we use public key hashes that are much shorter. And that table only contains your own keys. It doesn't contain anyone else's keys. So that wouldn't make sense because you don't have their private keys for obvious reasons, right? Then we have the vault service. So the vault has this table called vault states, which is essentially a key value store of the of a tuple, which is the transaction ID and the output index. So that's your coordinate for the state ref for a particular state. And then the serialized bytes of that state, which I've omitted here because they're kind of long and there's no point putting them here. But it's just a key value store. And then you can create a materialized view for each one of your state objects. That's where the custom schemas come in, the linear states, fungible states, whatever states, tables. And so you can kind of explode out a deserialized, materialized view of your state object. So you don't have this kind of long string of serialized bytes, which is not really very helpful for querying. So as well, because there is a one-to-many relationship between state objects and parties, there is another table that maps a state ref, so the transaction ID and the output index, to the owning, participation key, what have you, holding key for a particular state. So you usually only have one row for each state, because for a token you would only have one holder at any time, probably. But for a linear state you could have n number of holders. So you would have n number of rows for each state object in that table. Okay, now in another world, the identity service world, whenever we create a new public key pair on our node, if we want to, we can also add a row in the public key hash to external ID table, which is basically a mapping of the hash of the public key to the account ID, okay? So that's very important. You need to do that. It's optional. Not every public key has to be associated with an account, but if you want to use accounts, then probably most of your public keys would be. Now, we have all of the data that we need now to create a mapping between state objects and accounts. So we have this joining table here, which contains the state ref of the state, so that's the transaction ID and the output index. The public key hash, so it's essentially each row in this table, but with an additional column added, which is the external ID column. And the reason why you can't do it in this table is because at the time when the state is stored by the vault, you don't really know, you don't have this data. So this is a view that is created at runtime by Liquibase, pretty much. So it's an immutable Hibernate entity that exists in the vault schema, world, that maps state participants to account IDs. So it's basically a join on these two tables here. And then because this table has essentially, I don't know why that's there, but this table has a primary key, which is a state ref, you can join it on the vault states table at vault query time and essentially query by multiple factors, like whatever properties you've got in your state, whether it's consumed, whether it's relevant or not, what the notary is, who the issuer is, blah, blah, blah. So you can combine all those regular query stuff that you do today with the account ID as well. So what that gives you is an additional capability to query the vault by account ID. And I'll talk a little bit later on about how you do that. There's some other tables up here as well.
Roger.
Hello? Hi, Simon.
Sorry, quick question. Hey, just looking at this, maybe a bit of a silly question. If I'm choosing to keep all of my accounts in a separate Corda database, does this mean I'm going to have to do cross-database Corda design to link my keys to my accounts? In the case of Lendicom, all my accounts, which will be what the portfolio manager is managing, they're going to be in a table in a Corda database separate from the vault.
So none of these tables are in the Corda or in a Corda. They're all so as it says on the slide, all the tables in the yellow box are part of the identity service. All the tables in the green box are part of the vault service, and all the tables in the blue box are part of the key management service, which are all core node services. So the only tables that you would have as part of your Corda are the materialized views for any custom states that you have.
I think what Simon also is getting at is that they would have IDs that exist outside of Corda, so like big company account X somewhere, you'd have to do a join between big company account X somewhere off Corda to one of these UUIDs on Corda.
Yeah, I mean that's out of scope for this. I mean, yeah, if you want to do that, then obviously, yeah, you've got to create a new table and then join from this table here, the external ID, to whatever set of entities that you've got representing your, I don't know, off-ledger data. Maybe you want to add name and address and other paraphernalia for all of your accounts. But I think your question, Simon, was also around like migration of data between Corda apps. And I guess the answer is no, you don't have to do that because all these tables are defined at the vault level, sorry, at the Corda node level. Does that make sense?
Yeah, I get it feels like it's there's a more complicated question around an account is like an LUI, a legal name of a company, a tax ID, and maybe $1,000 that's been assigned to that in terms of, let's say, a loan. That is going to exist in the Corda. And if I want to share that with other nodes,
what does that mean? Sorry, that exists in the Corda. What does that mean?
because let's say, for example, Lendacom. If I'm a portfolio manager, I'm logging into the Lendacom application, and my customer data is stored in a Corda app database. So it's a SQL database, but it's not the Corda vault.
Yeah.
So if I, as a portfolio manager, decide I draw down, I'm a lender, I draw down $1 million for account BlackRock. Okay, so I'm assigning $1 million to that account BlackRock. I may then assign another $1 million to account Barclays. BlackRock and Barclays can't know about one another. My point is, when BlackRock and Barclays log into their view of Lendacom, they'll want to see their own, which would be effectively a state. The fact that they've purchased X amount of a particular loan, that will all exist in a Corda database. So I guess my question was, how is the vault going to interact with the Corda client database in order to make sort of the business logic that I just described work?
I think you're conflating a couple of things with the question. So you're talking about BlackRock owning XYZ state or whatever. That's all held within the vault service schemas, right? And it always will be. But I think what you're talking about is the additional metadata for a particular account that, yes, would be held in the database for a particular, in the database table that is created by a particular Corda app. And yeah, I mean, you can do whatever you want with those tables, right? You can add database schemas to deal with individuals, companies, what have you, and all you do is just join on the external ID column in the public key hash to external ID table, and you're good to go. And then you touched on another thing around, well, you know, BlackRock can't see, I don't know, whatever else is states, and we'll cover that later on in the presentation.
Okay, sounds good, thanks.
Yeah, Simon, also, I think it's a slight misunderstanding of how accounts and states link together. BlackRock exists as a UUID and a set of keys. There is no BlackRock, for example.
Yeah, they don't have identities.
Yeah.
That's an important thing to note.
So, yeah, if that's what the plan is for using accounts, we'd have to talk about it, because they don't exist anywhere apart from a mapping between UUID XYZ to a table row saying BlackRock 32 Throgmorton Street, for example.
Yeah. Okay.
Yeah, I mean, it sounds logical. Go ahead.
No, sorry, go on, Simon.
What I was going to say is there'll be, in the particular node that we're talking about, the portfolio manager will own the node. So there's 1x500, whoever owns that node. But within that, let's say there's 100 accounts, I'm assuming they all have UUIDs, which will be linked to keys, and the Corda can be designed such that money can be allocated to each of the UUIDs, the rows that Roger described as metadata. So, I mean, I think the question's been answered. It's just around Corda design and how you present and want to share that metadata with the end users.
Yeah, okay, cool. Thanks, Simon. Right, APIs. So there's a couple of new APIs. The first one is actually not new. It was added in Corda 3, and that's fresh key for a particular external ID or UID, account ID, whatever you want to call it. And that updates the public key hash to external ID table as well as the persistent key table. So it updates both of those. Whereas fresh key that doesn't take a parameter as a UID doesn't update the public key hash to external ID table, right? So that kind of, it does it in one atomic transaction. Identity service, new APIs. We've got register key, and that allows you to register a public key to a party. So the party being the host node for that particular account, for that particular public key. And you can optionally add an external ID as well. So the reason why the external ID is optional, because not all public keys are associated with accounts, so you don't always need to associate a public key to an external ID. So let's say if you're just a regular node using confidential identities, then you would provide a null value for the external ID. You don't need to map it to an account. But as to Alex's question in the morning, he asked, well, you know, can you map a public key to an external ID after it's been created? Well, yes, you can, but the way this API is designed, it assumes that whenever you map a key to a party, you also map it to an external ID at the same time. Maybe this doesn't necessarily fulfill what Alex needs, but I guess we can talk to him about that afterwards. There are two other APIs. The first one is external ID for public key. So if you provide the public key that you have, it will tell you which account it belongs to. So that could be a public key corresponding to a private key, so a key pair that's generated on your node, or it could be someone else's public key. So you can look up accounts for any external IDs for any public key. Then as well, there's an existing API on Identity Service that allows you to look up the host party for any public key. That's at the bottom, well-known party from Anonymous. You've probably already used that already. So if you give it a public key or an abstract party, then it will tell you the party that it belongs to. And then there's another API, which is, how shall I say, it's maybe somewhat experimental, because we need to do a little bit of testing on it, but it will, if you provide an external ID, it will return all the public keys that are associated with that. Now, as you might imagine, that list could get quite large. So we probably need to introduce some concept of paging around that. But for now, it just returns a list of public keys. And that is quite useful. If you want to, say, reuse a key that you already know belongs to a particular account, then you don't need to request another key. Or if you want to do, I don't know, some kind of lookup of account to public key, then you can do that with this API as well. And the account service uses this. Any questions on APIs? Okay, cool. So what is the account service? Well, it's just an interface, which is a Corda service, and it's got a bunch of methods on it. It's pretty straightforward. Yeah, what I will do actually is go through all of those. But firstly, I want to introduce the account info. So the account info is really just a very simple state object. It's a linear state, and it contains an account name, a host party, and an account ID. Ignore status for the time being, because it's not really used. So the idea is that the account names are not unique at the network level, because how can you enforce that? You can't really. But a tuple of account name and host party is considered to be unique at the network level. Likewise, the unique identifier, which is a 128-bit number, can be considered to be unique at the network level, because it's unlikely you're going to get a collision. So you can address an account at the network level by a tuple of name and host, or by a unique identifier. So if you have either the name and the host, or just a unique identifier, you can find out whether an account is on a particular node or not. So that's the account info. It doesn't contain a default public key. We decided not to do that for a number of reasons that I won't go into at the moment. but if you want to ask a question about it later, then you can do.
And it's a state.
Oh, it's a state object, yeah, it's a linear state.
It's issued by the host. So
Yes.
you have verification that the host has issued this account.
Yeah, so that's a good point. So the host node would sign the transaction that issues this state on the ledger. It can be shared with other nodes. So this is how you share information about accounts. The account service, so it's simple APIs, list all our accounts, list the accounts for a particular host, list all accounts, create an account by name. You can't create an account by ID because then you'll be able to create an ID clash potentially, so we're not allowed to do that. Return all the keys for a particular account, get the account ID for a particular key, return the account info by unique identifier, public key, or account name, and share account info with the party, share a state with another account. I'll go into that in a bit more detail later because it's more complicated than you might think. And share state and sync accounts, and I'll talk about that a bit later as well. So those are all the APIs that are available at the moment. We can obviously add more, but for now that's all that we understood we needed to add for the first version of accounts. Any questions? No? Okay, cool. So typical workflow, super easy. Create a new account. Here we have an account for Maximus, then once Maximus has an account, you can get the account ID of that. So this actually returns the future. So I get the future, get the account ID from the account info, and then I create a new key and assign it to the account ID. So it's pretty self-explanatory. Actually, with the confidential identities flows and the accounts flows, this is kind of all done for you. So you don't really need to do any of this manually. You just provide the account ID that you want to create a new key for, and it just does it for you. But if you do want to do it manually, that's kind of how you would do it. So once you've done that, then you create a state on Ledger. You add this public key as a participant key, and you commit that transaction to Ledger such that you store the output state in the vault. And when you do that, that state object is now mapped to Maximus's account. Happy days. So, how do you query the vault? Well, this is really important. Honestly, do not get this wrong, or your Corda will not work in the way that you think it will. And it's unfortunate that this is slightly confusing because it's just the way that the API had to be developed, because accounts was not added in the first version of Corda when the vault query criteria was available. So what you have to do is create a vault query criteria that specifies the account IDs that you want to query states from. Okay? If you don't do this, then if you omit that, then you will return every fungible token stored by that node. So it won't discriminate the query by account ID. And then if you do that, you'll be like, why am I getting back all of the state objects? I just want to query by account. So you always need to do this. If the account ID is not known by the node, or then it will return nothing. Okay? If you put the wrong account ID in, it will return the stuff for the other account. So the permissioning for accounts, or the view of what is in a particular account, has to really be controlled at the application level. As I said in the prior presentation, there's no isolation at the persistence level. Okay, so you have to be very careful about what you're doing. If you try any other way to query for states, it won't work. So this is the only way to do it. So do take note of that. And we've got multiple examples showing how that needs to be done. But to be honest, we probably need to add more documentation. So I talked a little bit about these. They're fairly self-explanatory. Realise I'm kind of over on time. I think that's good because Kash is doing the next presentation and she's not here yet, so I'll just continue for the time being.
She just walked in.
Oh, she? All right, great. That's good news. Request account info, that's pretty simple. So I say, I want to request account info for account ID blah from node blah, and it will either return the account info for you or it will return nothing if it doesn't know about that account. So the assumption is if you know the ID or you know the name of the host, then the host will respond with the information, right? So you probably learnt about the ID or the name out of band or through some other application or something like that. Share account info, well, it's just the opposite of request account info. Request key for account, so this wraps the confidential identities flow that Will talked about in the morning, and that allows you to request a key for a specific account. So if I want to request a key from Stefano's node for Alice, account Alice on Stefano's node, I tell Stefano, create a key for Alice, assign it to Alice's account, and then a key pair for Alice, and then send the public key back to me with the proof that it was generated on your node. And that's what that flow does. And you'll probably find yourself using that flow quite a lot when you're using accounts.
Roger, you said about the reuse not being available at the moment.
So yes, reuse is, it is actually available with this API account keys.
Not plumbed in.
Yeah, not necessarily.
We got a question from our favourite Andrew Morgan about it about 20 minutes ago.
Oh, great.
Yeah.
In that request key, in the context there, why wouldn't Stefano have already had the key pair created for Alice's account?
Because he's creating them on demand when someone asks for them.
But the Alice account existed previously, isn't it?
Yeah, so Alice's account would exist. The assumption is Alice's account exists already. And the assumption is that you generate a new key pair for each transaction.
Okay.
So there's a bit of logic behind it, because there's no guarantee that that key that I previously gave you, I still have control of the private key.
Yeah.
So some companies want to just do a key, destroy it, and get rid of the key so that it can't be spent again. So we have to contact you again to say, one, is Alice still on your node? Two, do you have a key available for her? Because, you know, the end goal is eventually to maybe move these account keys out of the node, and you might not have access to the signing key that you previously shared.
Yes, good point. So if you there's that API on the account service that allows you to enumerate all the keys associated with a particular account, and that account might be hosted on another node. If you take one of those keys and you reuse it in a state, there is no guarantee that the other party still has the private key for that. I mean, it's not the biggest deal. All that will happen is that you send a transaction to another node that can't be signed. So they'll just throw an exception and you'll have to redo it again with a new key, probably requesting a brand new one. Okay, share state with account. So this is, I don't know the code name for the customer that requested this, but a customer did request it. And they wanted to be able to send a state to a particular account. And
Simon's.
yes, and this is related to the question which Simon asked earlier. And this is quite an interesting flow, because as I noted, you can't permission, there's no isolation at the persistence level, so all this permissioning has to be done at the application level. So we added a new entity in the accounts Corda called allowed to see state ref or something like that. It's got a very descriptive name, so you know what it's for. And what it does is just a mapping of a state ref to an account ID. And if your account ID is mapped to that state ref, then you're allowed to see it. There's a custom query criteria that can be used in conjunction with any other query criteria that will discriminate the Vault query based upon the rows in that allowed to see states table. So crucially, this is done at the application level only. It's not done at the persistence level. So you need to make sure that you get this right and your customers get this right in their Corda apps. So let's say if I send a state to Stefano only for account Alice, assuming that at the application level, at the Corda app level, all the Vault queries take into account the data in this allowed to see states mapping, then only when Alice logs in and the Corda app queries the Vault for only Alice's states, then she will be able, and only things that Alice can see, then she will see this. Bob and Charlie and I don't know, Demi won't be able to see the state because there's not a row permissioning them to see the state in this table.
It's a two-phase thing. You have to create the account, and then on the node that's going to be doing this permission viewing, you have to create this allowed to see mapping that just says account X can be viewed by remote user Y, and that's completely at the application level, because that's not Corda stuff anymore. That's that's web level you have a database somewhere that maps a web user to an account, list of accounts they can see. It was done on purpose to keep it separate from the internal logic.
Exactly right, yes. So I think that is that. And actually, the reason why you have to do this is because when you're actually a participant in a state, it's easy to allocate it to an account because it's done by public key. But if you're an observer in a state, then there's no way to do that because you don't have any public key that's actually in a participant in the state object. So if you want if you want an account to observe a state but not participate in it, then you need to use this share state with the account flow. Share state and sync accounts. This is pretty simple. You just share a state ref with another node, and it sends all of the confidential identities participating in the state. And as Will noted in the morning, you can then contact each of the respective hosts for those confidential identities and request a proof that they actually generated those key pairs. And then it also sends all of the account infos along with the participation keys. So it's pretty simple. If you want to synchronize a state from an account's perspective, then you use this flow. All right, last slide, because I'm kind of running out of time and probably boring you guys by now. This is not a good slide because it's difficult to see. However, you will have the deck and you can look at it at your leisure. But what I think it illustrates quite nicely is the relationship between accounts and network identity. So as you know, in a Corda network, a permission network, we have a doorman, and the doorman allocates identities to nodes. And now, each node can host multiple accounts. Happy days. Though those accounts are not identities. They are not identities. They are just a way to partition the vault. Okay? However, we can allocate an identity to those accounts. They are identifiable, so to speak, but they are not identities. So what we can do is, let's say we can create an identity state that has a string name, let's say allocated to Roger, and it has a list of accounts. I can then include a reference to all of the account infos that pertain to my accounts. And then I can send that to somebody and say, hey, all of these are all my accounts on XYZ nodes or whatever. But that's an identity solution that is kind of built at the application level, and it's not at the node or network level. So I guess here we're just saying that each node can have multiple accounts. Each identity can have multiple accounts spanning across different nodes. However, it's up to you how you want to allocate an actual identity to those account holders. It's exactly the same as, say, I've got an account with HSBC, I've got an account with, I know, Monzo or whatever. Maybe that's HSBC, that's Monzo. I've got two accounts, one with each of them. Happy days. I'm Roger. I could create a state that represents my identity. I guess I've got a passport. I mean, you can do the same thing with Corda, but crucially, it's up to you to do that at the application level. Make sense? Okay, cool. Roger, Caroline. Oh, hey, sorry.
I have more of a question about I guess if I was trying to figure out should I have nodes or should I have one node with loads of accounts, how do you walk someone through trying to make a decision about that? Because it seems that running accounts are much cheaper, it's more flexible, you can kind of play with it a lot more than you could with the node structure potentially.
Yeah.
Have you had many clients ask, why would I not just have one node with tons of accounts on it and then build my own stuff on top of it?
It's a very good question. I mean, I guess it's a question of trade-offs, I suppose. So if you, let's say you actually just want one node and you have accounts on the one node, well, you don't have any distribution or decentralization of responsibilities or control there, right? Everything is de facto controlled by the node operator. However, if you have split things into multiple nodes, then you have a decentralization of trust and responsibility across those node operators as well. But, of course, the account holders still need to trust those node operators.
Yeah.
But then that's, I guess, a decentralization question. What about cost? Well, obviously, running individual nodes, but each one of the instead of having accounts on those nodes, having a node for each one of those account holders would be probably very expensive. I mean, let's say you had 10,000 parties on a network. I mean, I don't know what the average cost is to run Corda in a HA deployment for a year, but I suspect it's not cheap, and that's a lot of money. So you might want to kind of fold some of those customers into accounts on the nodes. Maybe Mike's got a better view here.
I didn't really pay attention. I was thinking of my questions.
Oh, right, okay.
So, there's a natural transition. So this was created in response to the customer that Simon was talking about.
Yeah.
They have a very weird distribution of activity. You have like 4 or 5 nodes that will do thousands of transactions a day, and then you'll have like 500 that will do 1 a week. It makes no sense to keep a node up and running in fully fault-tolerant mode for that 1 a week transaction, right? So it basically comes down to how much you'll use your node. And the current design that Roger is talking about gives you a very nice, easy way to transition from being an account to being a node. So if I'm currently Stefano Franz at big account hoster 1, and then eventually I start to lose trust in them, or my activity levels reach a point where it's financially beneficial for me to become my own node, I can just transition away from that account hoster. I generate a new account. I'm still Stefano because I've got a name, but instead of being Stefano at a big account, I'm Stefano at Stefano nodes, and everybody else will interact with me the same way.
Do you think it's like due to the volume of business?
Yeah, basically. It's just because unfortunately Corda doesn't support like hibernation. The dream is Corda shuts down, a message arrives for it, it wakes up, processes it, and then shuts back down. We don't have that at the moment, so it has to be up all the time to consume a message, and it gets very expensive. Especially talking about literally hundreds of customers doing 1 or 2 things a week.
Yeah.
But yeah, it's interesting as a network thing, because the question comes, why would I pay £1,000 to have my own node when I can just get an account for free?
Especially if there's like business network operators who are operating nodes for those people anyways. So it's like, why wouldn't they just have 2 nodes?
You make a very good point. And we've raised this before for the network people, but
I just don't know. We don't have like a line that we advise people on. Or I guess it depends when this is ready.
I mean, it depends on the use case, I suppose. I guess it's probably worth sitting down and having a chat about it, and figuring out what different factors you need to consider. Off the top of my head, cost, like expertise of like, can you actually deploy and administer a node? Like how decentralized do you want your network to be? Bearing in mind, as I said, the node still controls the key pairs. That's a different story when we manage to move signing out into separate processes and we have wallets and things. But there's probably other factors to consider as well that I haven't thought of. But yeah, it's a very good question.
Is it possible to...
Roger, just sorry, someone else is speaking.
Sorry, Simon. Yeah, there was another question in the room.
Okay. Is it possible to reuse a confidential identity across transactions to sign more than 1 transaction? Of course, I do understand that the size of the data that you need to keep when creating a new identity are not important compared to the size of a blob, but still you need to create some extra data. But yes, is it necessary or can you reuse?
You can reuse them, but as Stefano noted before, if you we do store all of the public keys. We now store all of the public keys for confidential identities that you've seen before, but you've now guaranteed that the host node for that confidential identity, or the public key that created the public key, still has the private key. I mean, they probably do, but they might not. I mean, worst case scenario, you create a transaction for them to sign with the corresponding private key for that public key that you've reused, and they can't sign it because they don't have the private key anymore. I mean,
it's not actually the worst case scenario.
No,
so
you
get this last time.
Yeah, you get a trapped state that you can't actually move. Yeah.
So if I move, tokens don't require the receiver to sign. So it was done on purpose. Like, it's very dangerous to just assume a key is still live, because people will want to delete these keys if they generate. Like, customer over there, you know, if you're generating 100,000 keys a day, they will delete them. So please contact other nodes. It might send you back the same key and save all that time. We should always check that the key is active on that node.
Yeah, Stefano raises a good point. Yeah, I said the worst case scenario is they send the transaction back because they can't sign it, but yeah, that's not actually true. The worst case, it depends how the contract's written. Let's say if the counterparty is the only one that can, let's say you can create a state object and only you have to sign the creation of it, but then it ends up in a state where the counterparty has to sign it using the participation key for them that you added, but they don't have the private key anymore. Then you've got a state that you can't do anything with, right? It's kind of blocked. So yeah, you should always, I think you should always check you should always check that the other node still has the private key. And there's actually a flow for doing that. So you can provide a key that you already have and request a proof that it does belong to that node. So if you do want to reuse a key, I suggest doing that. But then that's kind of, from a time complexity point of view, it's the same as just requesting a new key.
I think one or two of the cloud providers we work with charge quite a lot for keys stored in HSMs, don't they?
Yeah,
I originally know. I think it was $5 per key per month.
As
$5,
$5 a key a month.
Yeah, so it's going to get quite expensive.
Well, I think we'd use that key wrapping approach where you store the keys in ciphertext in your database, and then you unwrap them by decrypting it with the key, the single key that's stored in the HSM.
That's how it works now, is it?
I believe so, yeah. Because the HSMs don't have that much storage themselves, so you have to use these kind of
master key in there.
Yeah, exactly. But yeah, that's a good point. Yeah, if you, as your key vault or whatever will bankrupt you.
How much time does this add? Because if you need to use the HSM for everything to decrypt the key, that's
nothing compared to actually building the transaction,
okay.
Sending it back as a. I mean, this is not high frequency trading like friendly, if that's what we're talking about. But the time it takes to send the 128-bit string, sign it, send it back from the HSM is nothing compared to the actual network latency, flow workers, and that kind of stuff.
Simon, you had a question?
Yeah, it was just for a response to Carl. I don't know what you tuned it. In the case of Lendicom, a lot of the commercial loan business is outside. So RBS would have an agent in the lender, BNP would have an agent in the lender. But in the US, a lot of buy-side companies will want to take part in the purchase of the syndicated loans, and the buy-side traditionally doesn't host anything. So because it's prohibitive to ask the lender to host a bunch of nodes on behalf of the buy-side, so accounts gives a way around for the sell-side companies who want to sell the risk of these large loans to act as both agent and lender. If they've got the accounts of the buy side, it makes their life much more easy and it's much more cost effective.
Cool, thanks Simon. It's a good insight into use cases. Cheers, that's useful, Simon. Question at the front?
Actually, what I want to ask is, have you ever benchmarked this account?
What do you mean by benchmark? As in
so
performance?
The performance, yes. The performance.
I will talk, the answer is no, but I'll talk a little bit about it in the last slide.
And another one is like, we already have the account library in the GitHub, and I'm not sure the API, I don't think the API is compatible with this account. We're going to be rolled out in the 4.3. There are some tasks need to be done in order to migrate from the library into this version.
Well, all the code on GitHub is pre-release code, so we don't make any compatibility guarantees at all. So if you've used it, then that's like your
It does say
it's pre-release, and we don't provide any compatibility guarantees.
That's why it used to be private, but we got pressured into making it public.
Yeah, it's quite frustrating really, because we get asked to make all of this code public, then people use it and then complain that they have to blow away their data and start again, but that's not our problem, frankly. So
what if some client, they need to use these fictions, functionalities? Do you have the plan to provide them from soon this month or?
So yeah, this is currently. So we're going to release a release candidate for it today, and it will be released when Corda 4.3 is released. But if they're using a prior version of this code, then they're going to have to blow away all their data and start again. So actually, I'll do the integration test example after.
Battery.
Sorry?
Power is about to.
Oh shit, thank you, well spotted. Performance, to answer your question. Oh, there's a latency there. So, I get asked this question a lot, like how an account's going to affect performance of a node. So caveat, I haven't tested any of this, but intuitively, the performance of a node that uses accounts should scale in exactly the same way as the performance for just a regular node that doesn't use accounts. If you think about it, what actually are we adding? Well, we're adding this new account info state. It's just another state in the vault. And we're requiring users to generate key pairs and send the public keys around. You have to do that if you use confidential identities anyway. So, I mean, imagine you have a very busy node that uses confidential identities to transact with. And, I don't know, they're doing 1,000 transactions per second, which is supportable by Corda Enterprise. Then how is that any different to a node that has 10,000 accounts that, I don't know, transacts, I don't know, or 1,000 accounts where each account is transacting 1 times per second, right? I mean, it's no different. Again, if you need more than 1,000 TPS on the accounts enabled node, then load balance it across 2 nodes, right? Likewise, if you need more performance from your non-accounts enabled node that's doing 1,000 TPS, well, spin up a new node, right? So I don't think it really has a huge impact on any of the functionality in accounts has a let's say a huge impact on the performance characteristics of Corda for any particular use case. However, the caveat is we haven't tested it yet, so we have to do some performance testing. If that changes, obviously I'll let you know, but I kind of doubt it will. Stefano, Kasia, you got any views on that?
I think the only, so a node by itself, plain Corda, after you add CIs to it, adding accounts is nothing.
Yeah.
So the CI is the big degradation in performance because of the network traffic.
Yeah.
But accounts it's just a wrapper around CIs.
Yeah, exactly.
So whatever CI can do, accounts can do.
And what's the use of CI then?
It's a network traffic. So each you will handle the same number of flows. It's just that each individual flow will take longer because it has to suspend. So you know I've got to contact you to get the key, and then go back to myself.
Yeah.
So that's it. That's the hit. So you can still handle the same throughput. It's just each individual transaction takes longer.
Yeah.
But if transaction performance is absolutely your driving force, you shouldn't be using this functionality. You should have your own nodes. You shouldn't be on a shared node. You should be whatever. You should be. This was done to help those clients that have low volumes.
But essentially, it's a latency issue, not a raw throughput issue.
Yeah.
In case. Yeah.
Because it adds an extra step.
How do you put it in presentation mode that changed IntelliJ?
Is it in view by any chance?
Can't find it. Oh, here we go. Just in the summary. Okay, so this is how you use accounts. Can you guys see that? Okay, cool. So what we're doing here is setting up 3 nodes. So actually, this uses accounts with tokens. And we're setting up 3 nodes, issuer, A and B, and then with just some pretty default parameters. And then we, I don't know, just wait on a future for all of those nodes to start up. Once they've started up, then we create 2 accounts on party A, so Roger and Kasia, and we wait for those flows to finish. And then and then this is a test, so we do some checking. We check to see that the list of all of the accounts on node A is equal to the accounts which we just received from that future that's returned. So that's using the flow to create an account via RPC, and that's just using a flow which wraps the account service just to get all the accounts on a node. So the reason why we create wrapper flows is that you can't invoke services from via RPC, so you need to create wrapper flows for them. Then we create 2 accounts on B, which is Stefano and Will. So you all met Will this morning, and Kasia sitting over there, who's going to present next. And then we check that all the accounts are that have been created properly on B. And then what we do here is share Roger's accounts from node A to node B. So we use the share account info flow, and we specify Roger's account, and we share it with the legal identity of the issuer. So that will get shared with the issuer. And then we check to see that I actually did store that account info. So we can see that that assertion, well, I guess you can't see here, but the assertion is true. It turns out to be true, unless something big breaks in the node, which shouldn't happen. So that's all good up to that point. Everyone following?
Yep.
Then the issuer would request a key for an account. So we pass it an account. This Rogers account is of type account info, so it's an account info state and ref. So from that, it knows the host, the account name, and the account ID. So the issuer can go to node A and say, hey, can you generate a new key pair for Roger's account, of which it does. And then I check to see that the key that it's created is, the host is the A node, which there's assertion there that shows that's the case. And then the issuer issues 100 quid to Roger's account on node A. So you can see here that we're using the token SDK. So 100 GBP issued by I, the issuer, held by Roger's anonymous key, or the new key that's created for Roger's account. And then we invoke the issue tokens flow. So this is demonstrating interoperability with the tokens SDK. There's no tight coupling of anything here, which is quite nice. So there's no concept of accounts in tokens. There's no concept of tokens in accounts. It kind of just works because it's coupled together very loosely via the public key, the participation keys, and state objects. So we can see here, once we've issued that, we get an issuance result, and then we can check that Roger does actually hold those 100 quid. So we can see here that we're using external IDs, vault query criteria, and we're querying by fungible state. We're not querying by anything. Usually you wouldn't just query by fungible state, you would query by something more specific, but as I know, Roger only holds like one state object. I can use a fairly abstract query, and it will return that one state, and I can check to see that the tokens that are created here is equal to the tokens that I have in the vault. So happy days, I just sent a state to an account. Then moving tokens between accounts on the same node, well, that is exactly the same process. So you request a new key for an account. So this time party A is requesting a new key from itself because Kasia's account is also on node A as well. So that's pretty easy to do. When we do this, we also need to create a new key for Roger's account because we need to create a change key. So what I'm going to do here is send £50 to Kasia's account and send the remaining £50 back to my account. But of course, I need to create a change key for me. So I use this new key for account flow that creates a new key and associates it with my account ID. And then I do a move tokens flow to £50 to Kasia's account, and then I put my key in as the change key, and then I do that, and then we do some assertions at the end. So we do 2 vault queries, one on node A for my account, which is here, and one on node A for Kasia's account, and there's an assertion which is true that Kasia has 50 and Roger has 50. So if you did a bulk query and didn't specify the account IDs, then you would return £100 because £100 is stored in the bot. So it's really important that you do this. I haven't demonstrated sending tokens to other nodes, but I guess we can.
It's the same.
It's the same thing. Yeah.
Nodes don't care if their accounts on the same node or they're not. Corda can now talk to itself, so
Yeah.
as far as everyone's concerned, it just works as if it's the same. And there's another feature in 4. Should I talk about the abstract party initiated flow?
Yeah, go for it.
So we added something quite important to Corda 4.3. So one of the requirements we got from a lot of customers is there should be no difference between an account party, i.e. a key linked to an account, and a real party. And unfortunately in Corda there was a clear separation. If you were an anonymous party, you couldn't initiate a flow with it. So Corda's now been changed, so you can initiate a flow with an abstract party. You don't have to do a lookup to have a well-known identity. So you can code your application regardless of whether you're transacting with well-known parties or if you're transacting with accounts. Corda no longer cares. It's just initiate flow, abstract party now. So and this was a requirement from Simon's group, because they want to be able to move away from being an account to being a node as their business grows.
Cool, thanks, dude. Any questions?
Where is this example node?
It's in the accounts repository under the examples module. So there's 3 examples. Sorry, hang on. Sorry, bear with me. Okay. Yes, there's 3 examples. There's gold trading that Stefano wrote.
That's one that demonstrates the share, the broadcast to an account. That's basically that demo and user permissions for web level stuff.
Yeah, so that's a good example for you guys to look at. Then Will wrote a sweepstake Corda app, so it's like a node that hosts accounts for gamblers, and you can create a World Cup sweepstake, create some fake results, and you end up with a winner. One of the accounts wins, which is quite cool. And then there's this tokens integration test that shows interoperability with other Corda apps, as well as sending tokens between accounts on the same node and doing bulk queries for accounts on the same node. So there's actually more examples as well, but those are the 3 best ones, I think. So I think that's it, really. That's the end of the presentation. Any questions at all? Any last questions? No, we're good. Lovely, thank you very much.
Hey Roger, Johannes here. So just a small one. So I remember Corda wasn't great with using applications as libraries. There was lots of debate around it. Has this been changed at all?
Tokens is not a library. There's nothing. There's nothing which. That problem only comes if you're doing interdependent contracts, in the sense that because that problem only occurs in the verify sandbox class loader, because accounts doesn't take any transaction verification logic. It's just distributing data and off-ledger mappings. You're good to go. Now, if you wanted to use account infos as, like, say, reference states and want to enforce their presence,
then you get the problem.
You'll have to do some clever dependency management. But in its vanilla case, you don't. In gold trading, there's a workaround. If you want, I can show you later.
But yeah.
Cool. And tokens is the same, so basically it doesn't have any contractual verifications, right?
No, it does.
No, the tokens contract code doesn't have any dependency on accounts.
Oh, no. There's no dependencies. It's all loosely coupled. But if you do look at the tokens code, we spent a lot of time on making sure that the Corda app dependencies work properly when you construct the class loader for the verification sandbox. So you can get a situation where you've got the tokens contracts and you create a subclass of one of those, and there was like various security issues that had to be taken into account. So I think tokens is probably the canonical example for how to do that, because Tudor spent a lot of time reviewing our code, and he's the expert in all of this stuff. So it's probably worth having.
Okay, cool. So simple statement. So if I'm using tokens, I don't have to bundle it into my Corda. I can just drop tokens as a separate Corda jar into Corda's folder, and it should just work.
Yeah. So no fat jars.
Awesome. Thank you, guys.
Yeah, no worries.
One last question from Peter.
Cool.
How do you disable an account?
It's a good question. So I guess that's on the roadmap for future features. But let's say if we were going to design a feature that allowed you to disable a Corda app, well, there's a status in the account info which is enabled, disabled. I guess you would flip that to disabled in the account info and then distribute the account info to everybody else, so they're aware that the account has been disabled. And I guess you would need to find a way to essentially retire the states. So presumably if an account was to be disabled, it would either be because the account is no longer needed anymore, at which point there should be no states associated with it, or maybe the account has been disabled because of some compliance violation, at which point you add a flag and say, look, I refuse to generate any more keys for this particular account, and therefore it cannot transact anymore. Or if indeed it's not required anymore, then I guess you can delete the key pairs. All the states are not required, so maybe you can delete those and be done with it. But I guess state deletion is, I guess as Ivan knows, it's definitely a topic for conversation that can span a long time. So we can maybe talk about that another time.
There's a dirty hack way of doing it at the moment, because if you're a well-behaved app, you should be contacting the other node for every single key. If that node no longer has the table record for that UUID, it won't issue new keys. So if you wanted to go and delete that row from that table that Roger had before, the external ID to link table, it would stop. But that is unsupported behavior. For exactly the reason, Roger, we haven't had an ability to.
Cool, thanks, Stefano. There's a follow-up question from Peter, which is there any trick to do this at the moment? I'd say probably what you can do is you can wrap the accounts flows with additional flows that check to see whether the account is enabled or disabled. If it's disabled, then just throw a flow exception and say this account's disabled. And then in all of the flows that you create, you'll probably want to wrap the token SDK flows with a check that checks to see whether the account is enabled or disabled. If it is, then terminate the flow.
Actually, so Roger says a good point. In Corda 4.1, we added the ability to override responder flows. So there's nothing to stop you as super compliant node X to override. So the flow that responds to the request key flow, you could write your own one that checks some off-ledger table of what nodes you were happy to respond to. So that's built into Corda. It's the flow overrides mechanism, which was added for B3I.
Okay, cool. Thank you very much for all the questions. Thanks for listening. Let me know if you have any other questions offline, and hopefully I can answer those.